Okay, so how did the 2 or 3 structures that we have learned just now actually relate to the properties of your giant covalent molecules or your giant covalent structure? Okay, so generally your giant molecular substance or your giant covalent compounds, they are hard. Okay, so a large amount of energy is needed to overcome the strong covalent bonds between the atoms. Remember, one carbon is bonded to 4 other carbon atoms by covalent bond as they share the electrons. So covalent bonds are very strong bonds, and I need a large amount of energy to overcome these strong bonds. So they are generally hard. Okay, but for graphite, what is going to happen? Graphite, remember, one carbon is bonded to 3 other carbon. The last electron is delocalized between the layers, resulting in weak intermolecular forces of attraction or van der Waals forces of attraction. So weak van der Waals forces of attraction will mean that only a small amount of energy is needed to overcome these weak intermolecular forces of attraction between the layers, and then the layers can slide over each other. So therefore, graphite is always used as lubricant. Okay. Next property that we are going to look at is the melting point and boiling point. So generally, your giant covalent substances will still have high melting point and high boiling point. Okay, because most of the time we are actually trying to overcome the strong covalent bonds. So I need a large amount of energy to overcome the strong covalent bond between the atoms. Okay, but if we have to compare, your diamond, the melting point is much higher than graphite. Okay, graphite will still have high MP and BP. It will still have high melting point, boiling point, but it will be lower than diamond. Okay, because of the weak intermolecular forces of attraction between the layers, or the weak van der Waals forces between the layers. Okay, covalent compounds, okay, they are generally insoluble in all the solvents. Okay, especially your giant covalent, okay, they cannot dissolve in all solvents. Next one, electrical conductivity. Okay, so covalent, because they share electrons, they are non-conductors of electricity. Okay, but for graphite, what is going to happen? Okay, recall, to conduct electricity, I need to have what we call the mobile charge carriers, or the mobile charge particles. Okay, there are no mobile charge particles because they all form covalent bonds. The electrons are all used up for bonding, for sharing. Okay, but for graphite, each carbon is bonded to 3 carbon atoms, and then there's one last electron that's delocalized between the layers. So these delocalized electrons act as charge carriers to conduct electricity. Okay, so in other words, your diamond cannot conduct electricity, but your graphite can conduct electricity due to the valence electron that was not used for covalent bonding, and it is delocalized between the layers.